Good afternoon, gentle readers. Today is the January 12th. And in today's moment in motion, geometry is motion. So without further ado, let us continue as we usually so proceed in terms of just a regular sort of thinking about how it can be that moment and motion are once different things yet the same thing and comprised to make one thing. That in terms of what it is, what is physics, what is a theory, what is logic, what is philosophy, what is mathematics, what is science, what it is. This is a book by Bernard d'Espagnat. D'Espagnat is a Frenchman, and he's been the chair of a school of physics for 30 or 40 years. And he's written several books in the philosophy of physics. And a particular focus of his researches is of that of the quantum principles, the discretization, and the theories of atomism, the Democritan, the Planckian, these days the superstrings, where the atom is 25 orders of magnitude smaller than us, and 50 strings are just that much smaller than it. Small enough to be ultimately fine in the grain of a smooth continuum. It's continuum mechanics that really so result what it is. And in the study of quantum mechanics, then there's the idea called the Born rule for a scientist named Born. And it essentially establishes after the Copenhagen interpretation, which is a conference about 100 years ago, that it was decided that the old quantum physics, which is after electron physics, when they first established it, there was a subatomic particle, the electron. And it was established via experiment how to determine its precise physical quantities. That became the measuring stick for all such other matters as regards Avogadro's number. Essentially, it's reciprocal. It's inverse. That the two of those multiplied together make for 1 mole, a mole of a chemical element. And then that in all terms of matters of reaction, chemical reaction, that it so follows that according to stoichiometry, that thusly the exact amount of quantities can be made exactly specifically precise. The electron physics then is the entire concept that there are subatomic particles and that they have specific fixed quantities measured their values in terms of fundamental physical quantities measured like length and mass, space and time. So how those are kind of kept together today is that the System International or SI units are standardized units, measures of units of measure, systems of units. And then the National Institute of Standards and Technology, or NIST, has there's a section called Particle Data Group, and they produce every few years a publication called CODATA, CODATA, CODATA. And in it are the most current values for these precise fundamental physical quantities. So every few years they release updated tables of these measured fundamental physical constants, the size of the electron. And as to it are so related all the other quantities for the charge of an electron and the size of an electron. The charge and size of protons vis-a-vis that which is an amount of mass by this number, and as otherwise as follows: electron physics, that our discretization made electron physics, which made old quantum mechanics, the Copenhagen interpretation made for the stochastic interpretation and the statistical ensemble. Today is our unified field theory with field occupation numbers. Basically, at any point in space-time, each of the numbers and their values with regards to the contents thereof. So CODATA releases this data every once in a while, every few years. And what, as you might imagine, the values they measure get more and more precise. That quantum mechanics has been proved out to almost as many orders of magnitude and a few more as the atom is smaller than us. Similarly, general relativity has been proved out, in a sense, in some settings, 29 orders of decimal magnitude. So they measure these values and they get more precise. And so you'd figure it would really begin to hone in to arrive at more and more of these values. So anyways, as higher configurations of energy experiment come online and establish more precisely these values, the electron and other constants according to these systems of units and the entire theory, they don't just get more precise, they get smaller. It's an actual kind of thing that these real particles, the closer you look, the smaller they get. Much like our sky survey, the farther we look, the bigger it gets. Every few years, science finds that the age of the universe increased millions and millions of years. Every few years, science finds that the size of the electron gets smaller and smaller. This is framed these days in terms of what's called running constants, that at the extremes of the regimes of the Planckian, and which is a few orders of magnitude smaller than an atom in the theory, that the extremes of these regimes, that what happens is the running constants are kind of what come into effect for these quantum mechanics, as it's a continuum mechanics, that our conceit, our metaphor, that conceit is a word for a metaphor, a poesy, or otherwise just kind of a concept, conceptually, that particles go to points which are, of course, infinitely small and have no dimensions at all. Insofar as they do. What is continuum mechanics? So this gets into why that besides that we have the wonderful facility of the electron physics and the linear Dewey chart, which is the theory of how to compute the potentials in a circuit of electrons that in the aggregate, that they will jostle back and forth, and that the holes or the waves through them will go through. That it's possible to compute exactly precisely enough how these things are, that then combined with some other empirical concerns make for, the chip and the logic on the VLSI, very large scale integration, ultra large VLSI, in terms of languages like Verilog and sysHDL or whatever are otherwise just the usual descriptions of the traces of regular 2D or planar chips, that it's so exactly defined and determined for these kinds of things. And yet at the same time, it becomes more and more as of a continuum hypothesis. So the waves then, as we've been talking about a lot in Moment in Motion, the waves are still pretty much the most fungible models of electrons and photons, anything really. And then in terms of otherwise, there's also the radiation, which are waves. The waves are the action of energy in its exchange and transport in open systems and physics. So Desparniat's book here is a kind of study in terms of what would arrive at from these thought experiments after the theory, what would arrive at either paradoxes or the imponderables, and what make for contradictions. that can't really be explained to be acceptable by views at odds with each other or these kinds of things. And so what Despina has begun in this book on physics and philosophy is that I've only read 100 or so pages into it, and it's got a lot more. But he establishes for the philosopher all these different kind of pragma or rubrics of aspects of the instrumentalist, the operationalist, the realist, in regards to what we discussed here, kind of like the teleological viewpoint onto the ontological viewpoint, how that can be an entire thing. And so basically Despina is kind of on the side of that he can't quite reach past this this what Hegel provides as that the Kant sublime comes down and the teleological is brought with it, because that's basically outside the milieu of this philosophy that they find can be they can adhere to. And so at the same time, of course, his intuition always finds itself there, because it's quite so that an objective external reality for this realist perspective has that he's writing a lot into trying to approach the realist perspective and all the arguments against it from the simple matter of the insufficiency of the phenomenal senses to accomplish that. While, as we discussed here, there's this object sense and the number sense and the word sense that really make for it that equipping the philosophy with that makes for all of our inherited canon and dogma before logical positivism, and then bringing strongly to stronger logical positivism makes for that continuum mechanics can so improve the conceptual underpinning of physics and kind of equip it so that for Einstein it's his differential system, because Einstein wants a total field theory to cap off his theories of relativity and his attack on Newton, meaning his zeroth laws of motion, and for the angular and rotational and the linear and their bridges. That it's getting kind of interesting, this on physics and philosophy. And so when I first started reading it, I kind of thought it was poor, because it didn't really affect to put away the stochastic interpretation for a real wave interpretation, and otherwise these things. But he kind of does. It's a conservative and cautious approach, and it's didactic and extensive, and it's the result of about 10 years of him writing on this book, in terms of being a chair of philosophy and physics and writing this book. That I'll be interested to see how it goes, Despina's philosophy, physics and philosophy. So let's see what else is here. And another thing that I kind of relate to that is this Alain Badiou. So this is another Frenchman, and an academic in France, and this is a translation, or as of it is with regards to his studies about being an event. So being, of course, or sein, it's a German word, S-E-I-N, sein, being, is the idea of existence. And then after the 1910s or 1920s, after logical positivism, then they had this whole thing, like after the communists and Marx and Engels and that, and Marx and this existentialism was the idea how it could still arrive at when there wasn't really otherwise a teleological beginning of things, that that's just kind of like a placeholder, a stand-in for that, in the course of that kind of needing to answer questions of philosophy. And as for the personally objective and the personal relationship with teleology, which everybody has. I mean, anybody has their own philosophy. Anybody has their own psychology. Psychology doesn't work on everybody, and not everybody's psychology has that their copers aren't broke. But everybody has a working psychology, and everybody has a working theory. then philosophers of science and mathematics and philosophers of physics and logic get pretty strong opinions about what they can and can't be told, with the idea being that there is one at all. What I considered to be the best route, because then it doesn't depend on me or anybody else. It just is. So that's just like there's a stronger logical positivism, there's a stronger Platonism. For Plato is named a theory that there exist objects, mathematical, irregardless our existence, and that they're the perfect shapes, geometry, the objects of mathematics, the objects of logic. In this manner, it's for having that there's a strong Platonism, a strong logical positivism, and a strong mathematical universe hypothesis of a continuum and its replete nature, and foundations and central and primary and fundamental in the theory, what makes the simplest thing to pick up and put down for these things. And then we get into formalism and axiomatics and systems of inference, and then for all matters of theories of types and categories, as of up after sets and parts or boundaries and centers, or any of these kinds of complementary notions of a theory of logical objects as begin to have relations at all, and all the matters of what could result after quantification, logical paradox or not at all. And then as develops the theory of types and the ontological thereof, and then for the universals and particulars, the thing. So I haven't really begun to read Badiou at all, but as I looked at it before and I commented on it a little bit before, what he gets into is some of the ideas that there are reasons to re-examine what's the usual rule and regular in well-foundedness in Zermelo-Fraenkel set theory, for example, and examine and consider why that in the reflection on the theory and its complement that it would be kind of the opposite problem. In that basically that there's numbering or there is counting, and they're two different things. And so here, then there's just been usual general notions of concepts that there's the inductive impasse either way with those two with respect to each other, that they do somehow have this bridge, the pont, they meet in the middle, and then that can provide for us the same deductive result, so that way we meaning you or I or anybody can have that there is a true, constant, consistent, complete, and concrete theory that we can attain to. Then, besides that, in the fundaments, that such a thing can exist quite merrily, happily, and without contradiction as truth, and it's a real theory of truth, then all such matters of Tarski truth and stuff, or all our contingent theories that we weigh and balance and measure and examine and judge, exist in their own world of all their contingents. And then there's a common modality, there's a common temporality, and these are the kinds of things that can be picked up again because they had to be put down when the philosophy for quite some time simply had it on the side because it had this other requirements, desiderata, to make for how to handle quantum particles or a curved space-time that is not Euclidean, the discontinuities that now mathematics is coming around to where that can be put back together again. So these are among the reasons why it's kind of fulfilling to have then these very regular notions that there is the absolutes in these things, the absolute truth and this kind of stuff. Not that we have it, but that there is one. And because it wouldn't be scientific or logical to say there isn't anymore. For the resolution of logical paradoxes and for the modeling of quantum mechanics as the continuum mechanics, and for theories of relativity and space contraction and the resulting geometry, and Einstein provides a way forward from his theory for this himself. And quantum mechanics has superstring theory. That's what it's for. And so on. Space contraction and superstring theory. Gravity in the middle of fall gravity. Well, all right. Let's see then. So this is kind of trying to figure out a way to understand the concepts of D'Espagne and Badiou, and they're not the same, and they vary, but they both kind of comprise a context in a wider context of thought. They are together is for these sorts of approaches. It's a bit chillier today. It's a bit chillier as it's, the coldest part of the year, shortly after the solstice. When I was young, when I was a youth, I used to walk to school. And it was a few miles. It was a couple or a few miles. One winter, it was particularly cold. And I remember for a week or two, it was 50 degrees below zero. So 50 degrees below zero is very cold. And we got used to it. People became acclimated to this, it's not something that is very warm at all. And if there's a fact, then it's just that 40 degrees below zero is the same about in Celsius or Fahrenheit. I grew up in a place that was below zero about a quarter of the year. About 4,000 foot altitude. Let's see here. Multiple beam interferometry. That's kind of what we were looking at. This is a bunch of experimental methods. And it says getting into chromatic order. Chromatic is as of, there's a prismatic and the chromatic. So it refers as to color. And so you might think in terms of your theories of color as additive and subtractive. And then for pigments and filters. So as with the reflection of light after pigments or the projection of light through filters, then there's the additive and subtractive of those in what are usually considered primary colors, like red, green, blue, or otherwise red, yellow, blue in the additive and subtractive. And as with regards to how those comprise these combinations, which make this chromatic and prismatic, that optical light is especially kind of, it's its own kind of quantity in terms of the world of waves of what's considered otherwise when everything's a particle and everything's a wave and everything's energy, about as when it's like the only particles in the model that fit for these different kinds of interfaces and exchanges are photons or electrons. And that there's the consideration that the electron is basically bradyonic. That bradyonic means that the root brady, it means slower than. Whereas tachy is the root means faster than. So electrons are bradyonic and photons are tachyonic. Now you might consider that kind of a contradiction in terms of that light speed is neither tachyonic nor bradyonic. So how could the photon be tachyonic? Well, the idea is essentially it's as fast as it goes out. And in any medium that's not deep space in a vacuum, it's slower than its speed in deep space at a vacuum light. And then the idea is that any other particles in free space, unimpeded, only travel bradyonic. And then the idea is indeed that any things that are interactions in the massy bodies of any sort. An electron has a mass and a charge, and a photon has neither, but it does have energy, is the idea, is that just helps establish the boundary between those conceits, that those particles are really as form of moments overall, moments in motion overall, a large organized system of these things. This is the concept of the ray, the rays of light, thermal radiation, nuclear radiation, ionizing radiation, electromagnetic radiation, optical radiation. They're different things. The same sort of milieu. This is largely the realm of the empirical, where largely in the theoretical, they can be treated apace by particle physics, the standard model particle physics. While at the same time, they don't really have too much to say qualitatively, which is as where the particle zoo is the idea of all these different named particles, and or what are the interference or interfaces of the exchanges of waves. Not necessarily the standard model, but quite well explored in all matters of the fundamental particle physics. Hadrons and mesons and leptons and baryons and bosons and fermions, basically is obeying the statistics of quantum amplitudes. There's been some talk quite recently of the skyrmions. There's photons and photinos. Each on has got an eno, which is its supersymmetric virtual partner particle. The neutron and the neutrino, the electron and electrino, neutrinos and neutrino physics. These are basically when there's a shifting as of the wave about the supersymmetric symmetry conservation flux the other way. When there's, as after the running constants, that there's symmetry-flex, as after the dynamics of this superclassical. That's what the neutrinos are the flow, this flow of infinitesimals the other way, as whatever add up in that entire surface flow to affect this difference from what's the classical standard part in the middle. Standard particle physics has what's called a standard model, and it largely is this usual quantum interpretation. And the idea of the Higgs boson was that it was, when it's discovered, it would kind of have teetered the totter of this careful scaffolding act of the measured values of the particles in the particle physics, which, as we just discussed or heard from the beginning of this talk, according to NIST code data, change every few years, variable, or as due to the configuration of the experiment and the energy of the experiment. So anyways, the Higgs boson is supposed to be this last particle in the standard model, and to kind of validate it. It's also the first one kind of outside, because the Higgs field isn't really a field, it's just an interface kind of. It's not a classical field, it's not a potential field. It's something that a particular branch of theory could arrive at what exists according to kind of the push and pull of this models, according to gauging the proton lifetime and this kinds of some matters of nuclear physics that science is still figuring out, this tetrad of quantities as of the massy and the kinetic, the charge and the electrical, and the photonic and the light-like, and the nuclear and the radionuclear, called the weak and electroweak, the forces vis-a-vis the nuclear force holding atoms together, and then the mass of those atoms being, in the theory of something like fall gravity, that what imbues mass to the atoms is not this Higgs boson. It's actually it's just the atoms again, and their virtual partners are themselves, which kind of it helps explain why the graviton is a real particle. It's the atom in this kind of theory. And that includes this concept of what's called supersymmetry, because it's just a theory of some potentials. So it's supersymmetry what establishes this above and as part of invariant theory, conservation law, continuity law, a theory with a principle of least action and a universal gradient. Time reversibility has never been falsified. So reading about this in terms of using light, particularly. Light, of course, is with regards to the most primary information gathering sense of the human being is the optical and the visual. And as with regards to its immediate translation in a mental model to words, has for variously how the auditory and the visual together comprise the largest part of sensory awareness and situational awareness of the surrounds and the passage of time and stuff. In that sense, you might equip yourself in your mental model next to your object sense, general consciousness, and number sense and word sense, all quite abstractly, a sense of time, a time sense, and as with regards to whether or not that really helps establish such matters of the continuous nature of the other phenomenological senses, is basically that we have man and mind vis-a-vis animal and machine. We're machines, we're animals, we're men, we're mind. Men, of course, being neutral and just referring to thinking beings of the Homo sapiens sort, for example. So in that sense, for a philosophy of physics and all that kind of stuff, it can be a lot more simple for anybody to pick up what's kind of considered the strong Platonism, the strong logical positivism, the strong mathematical universe hypothesis, the greatest theories in terms of, from the theories of atomism and all such matters of the fundamental theories of matter and substance to quantum theory as a coherent thing, and then for cosmology, relativity, all such matters of action, of bodies and substance in the material, all one thing. Over time, it's quite usually this way, and many or most thinkers that come down as heralding logic and philosophy call themselves Platonists, and most such thinkers who come down from logic and philosophy heralding the scientific method, scientists. So where we left off with Berkowski was reading about plane waves and section 2.2. So, we were talking about the prevalence throughout of x squared plus minus 1 in terms of the systems of angles of incidence and reflection. And then in terms of trying to figure out how those would sum up and over is maybe what we'll get into next. So we're talking about internal reflection, and the quantities of impedance and what it means with reflection and refraction And then as with regards to diffraction, that we have these various models of the waves that have, whether they bounce and remain a globe, or when they bounce, they splatter and then reform exactly from that. So this idea of the super model of the wave is that otherwise its classical model is as a drop of water. That's usually that there's a surface tension, that in free fall it assumes a nearly spherical shape, it's a droplet. And then as with regards to that, otherwise those being mostly its classical properties, or as for a classical fluid. Then the ideas of these superclassical properties are as, for example, well, what if it bounced vis-a-vis that it splattered? Or what if when it splattered, it immediately reformed or reconstituted? For this attenuative and dissipative about the oscillative and the restitutive, and the reconstitutive and the having been attenuated. These being these notions of that for the principle of least action, it gets broken down for entropy, and entropy, its reverse, to make for the tendencies being entropy and the propensities being the second complementary oxymoronic definition of entropy, tendencies and propensities. As with regards to least action and action, where action would be as being either as a form of organization or emergent behavior and enthalpic, or otherwise is as for abstractly direction at all, in the following of inferential rules, the rulio. So here the author gets into total reflection. The reflection cannot be total if there is absorption of the sound energy in the lower medium. Introducing absorption as a matter of dissipation, and as with regards to the lack of the restitutive absorption, and an exchange and a boundary. It also makes waves. It's also just radiation. Whether or not it accretes, that it gathers, it coalesces, or accretes as a particle, is descriptive. Formally, the presence of absorption can be taken into account by assuming n, or K1, to be complex. Here we've had a lot of talk about the Gaussian and Eulerian interpretation of complex numbers, and then what with regards to whether the complex is meant to establish for reflections and rotations, or it's essentially to establish a separate screw space of integers, or it's set to establish basically properties of analyticity, are three different things. So when saying that there's to be complex numbers employed, it should be, and it could be, broken down into these different kinds of reasons why, so that the derivations throughout could be rewritten from disambiguating what is otherwise a collected, a common milieu for the things that works for all the things, as it carries all these different properties, thereby breaking it apart. It comes apart this way and can go back together this way. That just because it's been written into complex Gaussian Eulerian analysis doesn't mean it can't have a deconstructive account that ends up making for that it can be put back together as a more sensible and fungible thing for different approaches in the sensible and fungible, and is what make things tractable. This also reflects on the discussions about the deconstructive accounts of arithmetic and algebra. They're different. And also the deconstructive accounts of arithmetic for operations of division and increment. Also about trigonometry and trilateralometry. Formally, the presence of absorption can be taken into account by assuming n or k1 to be complex. We said n equals n naught, and this quantity 1 plus ia. Notice it's got this increment going on, and this is what's called the Eulerian Gaussian screw. To over the periods of revolution that it increases, it increments, makes for an addition formula after this sort of increment formula, where a big, great goal of all kinds of things in methods is to arrive at addition formula for product terms. Alpha greater than 0. Moreover, we denote sine squared theta minus this quantity n naught squared times this quantity 1 minus alpha squared is on the order of A, big A. That 2 n naught squared alpha is on the order of B. Then sine squared, this quantity sine squared theta minus n squared, the root of that, so, x squared plus y squared, where x is sine and y is n, equals this big quantity, the big A minus IB, that quantity, the root of that. Which would it be is on the order of two products of terms. Here it generally started being called x squared plus minus 1, and roots in those. So that each of this is squaring and boxing and squaring and boxing and making for a sort of milieu, how they so stand up and hold. Equals this quantity, big M sub 1 minus I sub m squared, where m comma 1 comma 2, m sub 1 comma 2 equals 1 over 2 to the 1/2, or root 2 over 2 to the negative 2 times this quantity, the square root of this quantity, big A squared plus big B squared, square root of that, plus minus A. The values of the square roots are always positive. For the reflection coefficient, we have big V equals this quantity, m cosine theta minus big M sub 2 minus I m sub 1, or this quantity m cosine theta plus m sub 2 plus I m sub 1, from 2.17. We then have for the modulus and phase, respectively, that the absolute value, or it written in pipes or vertical bars, is usually the absolute value or the determinant, or as with regards to the length of this quantity, equals square root of these two quantities, their quotient. The first one being m cosine theta minus m big M2 quantity squared plus m sub 1 squared, and the denominator being this quantity m cosine theta plus m2 squared plus m sub 1 squared. Again, kind of phrasing this x squared plus minus 1 and root m squared plus minus 1, and trying to figure out then in terms of these how to frame these derivations, and as with regards to category theory and morphisms, their shapes. The category diagrams and the arrow functors help to indicate the transitions from state to states, and it works pretty well for mathematical derivations as well. While at the same time, they should also be all writable as these formulas a piece, and like so, and they are. It's just that there's a suggestion that it can be making for rewrite rules according to what's called term rewriting or term graph rewriting, which are mechanical rules applied to a syntax and a grammar and a dialect in a language that can result in output. It's a translation according to it kind of mechanically. That according to like a meta-programming approach or code generation, that all such sorts manners of these kinds of formulaic derivations, first of all, have a structure, and then abstractly kind of have the structure. And then according to these properties, they really only build and exist as by their properties of the relations together, besides whatever they're so written as, they're literals. That the mathematical objects really fulfill all their relations. And for, again, that usually natural language, of course, has anything that you can write on a page and detail in full regards all its properties can also be spoken. So that's the usual kind of thing to figure out. Figure 23, it shows a diagram This case corresponds approximately to reflection of the wave at the boundary water-packed sandy ocean bottom for various assumptions relative to the absorption in the sand. So they have a boat and they emit a sonar ping, and some of it gets absorbed. This is their model of it, and then this is how it's so gone about to compute it. This is an approach that is irrelevant to understanding how things work, vis-a-vis given a clock cat 1 billion tries with answers you've fabricated until it just works out according to like the flow machine in its system. That training a neural net is kind of like taking a bag of cats and throwing it in the water and then keep doing that until one of them swims out. It doesn't really give quite an understanding of Schrodinger's wave equation. I just made that up. So when we talked about Lefschetz, he's an algebraic geometer, and he made a comment about that the objects of geometry and higher geometry after, and maybe it was after Poincaré and analysis cetus and stuff like that. He's like, this is the way. We're gonna gaffe the whale, and he meant that as a very proud and a majestic and important thing. And the comment was that a gaffe isn't always a gaffe, because the verbal gaffe means to say something is like open mouth, insert foot, this kind of thing. So the metaphor of that neural net classifiers is like a way to skin a cat, is that it's not a gaffe in either of those two senses. For various assumptions relative to the absorption in the sand, we see that for alpha equals 0.1, magnitude V differs substantially from unity for all the angles of incidence except theta equals pi halves. In the same drawing, we plot the phase psi theta. For the case alpha equals 0, we note that equations 2.25 and 2.6 are also valid for n not greater than 1. Energy considerations, section 2.3. As is seen from equation 2.11, the pressure in the transmitted wave will be 1 plus V times greater than in the incident. So here it introduces pressure. And pressure is kind of the motive force, so that which has drives the propensity to act. As a simple definition, as we only start with these terms of attenuation and dissipation and oscillation and restitution, and their corresponding tendencies and propensities, vis-a-vis those being kind of the cardinal directions in terms of then otherwise this open model of physics of a way, spherically symmetrical yet linearly classical. As an example, we take the reflection of a sound wave at the boundary air-water from normal incidence from air. So, as of bouncing off the pond. Here, rho equals 1.3 times 10 to the negative third grams per cubic centimeter. Rho 1 equals 1 gram per cubic centimeter. C equals 333 meters per second. And C sub 1 equals 1,500 meters per second. From equation 2.18, we obtain that big V is approximately equal to 1. Thus, the pressure amplitude in the water will be twice the pressure amplitude in the incident wave. So this kind of reflects one of these doubling spaces in the notion that it's approximately on the order of twice, whether that's a heuristic or here is with regards to that's what's so derived from these two quantities. It's almost as like it's so natural how that kind of thing sorts out. That in terms of many cosmological models of contents of the universe, they're described as gas models, and with regards to pressure, and overpressure reflects some of these superclassical concerns. So, do water and air naturally just have this property? Yeah, they do. Conversely, if the wave is incident from the water on its boundary with air, then exchanging C and C sub 1, rho and rho sub 1 and 2.18 we find, taking the smallness of the ratio rho C over rho 1 C1 into account. V equals this quantity rho C minus rho 1 C1 over rho C plus rho 1 C1 equals negative 1 plus 2 rho C over rho 1 C1. It's approximately equal to negative 1. And big W equals 1 plus V is approximately equal to 2 rho C over rho 1 C1 equals 5.8 times 10 to the negative 4th. I.e. the reflection coefficient is close to negative 1, but the amplitude of the pressure in the transmitted wave is close to 0. Here is where then I'd look to try and understand the stop derivative, and that being a sort of way to try to frame these things where the floor falls out. Thus, in the transition of a sound wave from one medium to another and vice versa, symmetry is lacking relative to the values of the sound pressure. I don't know. It's a continuum boundary. It's a symmetry-flex. However, we shall show immediately that such a symmetry does exist relative to the components of the energy flux density normal to the surface. So flux density helps affect it, kind of in these model of the particle-ons and the particle-enos. That this flow and flux are complementary quantities and really reflect quite omnipresent sort of thing in usual models of wave dynamics and moment in motion. Geometry is motion. The energy flux density in the incident wave is equal to p squared over 2 rho c, and its quick projection on the z-axis will be I equals rho squared, p squared over rho c. So that's often, I is often a variable, capital I, big I is often a variable for a moment. I equals p squared over rho c cosine theta. There is a similar quantity in the transmitted wave. I sub 1 equals p sub 1 squared over 2 rho 1 c1 cosine theta 1. The ratio will be I sub 1 over I, except, or no, I sub 1 over I equals rho c p sub 1 squared cosine theta 1 over rho 1 c1 p squared cosine theta. But p1 over p equals 1 plus v, or in as accords with how the derivation is that it so follows and carries that, here that is attached to the Eulerian and Gaussian, and as it can so be in terms of the revolutive. And using equation 2.16 for big V, we obtain I sub 1 over I, or after, the incident, this is after and before, so after over before, equals 4 times this quantity cosine theta over rho c, cosine theta 1 over rho 1 c1, so after times before, those two quantities, times this quantity, the cosine theta over rho c plus cosine theta 1 over rho 1 c1, that quantity, that sum, taken to the negative second power, or 1 over that squared. Here is this written that according to roots and powers, that negative powers can be used to represent the inverses and reciprocals according to division in the positive powers. And as with regards to then the idea of the stop derivative from all the different descriptive differential dynamics, what relevance that would so have in terms of any such matters of the operator calculus that admit an infinite range of integers, as from infinity on down to 0, down onto negative infinity, vis-a-vis negative 40. The latter expression is symmetric relative to the quantities, referring to the upper and lower media, and therefore does not change upon reversal in the direction of propagation of the wave. We'll see, even if just a few pages of this kind of work, which has as its goal and the lot of work that went into it to reflect these fundamental characters of these elementary objects with their mathematical behavior is that it intends to reflect on the mathematical behavior of objects writ large and all these kinds of things. So it's really kind of a special thing to be able to start to deconstruct these systems of these theories of arithmetic and algebra and geometry all together, function theory and topology, all one thing, that it helps to break these things down kind of in this way, as what so results for that, then there can be kind of a didactic, principled approach to a treatment of these things usually and generally. Well, I shall so hope you have a great day today. Although it's cold outside, it's nice and sunny. Solar radiation is up a bit. Not quite enough to get the globe turning, but it's a thing. So then with regards to, trying to figure out what else to study about moment in motion, that geometry is motion. Here, what has kind of come up today was a couple things. And so one was the idea of the running constants of particle physics, and then some ideas about the bridges of Einstein, the one that's out at the extremes for Einstein and Podolsky and Rosen, and the one that's right in the middle with his second most famous equation that nobody's ever heard of, Einstein's bridge to space contraction. So that's just, it was kind of a talk about physics, and then there was talk about the philosophy of physics, where what it got into was the idea that the philosophy of physics of science and then the philosophy of physics of reason are two things, again, that are one thing. And that it's not so bad to have them together. Although maybe for a long time it was important to convince, computers that they couldn't have it all, so they, so they wouldn't try, but, or at least to indecision or paralysis or these kinds of things, but it's not really a thing. And then there was a consideration of some of the ideas of the light-like and the tetradic quantities, because the weak and electroweak forces, although it's like the very slowest and oldest things of the universe, this, the lifetime of a proton or this and that, are reflective, essentially, of light and its tachyonic nature in terms of supersymmetry, in terms of the virtual particles, in terms of the definition of the flow and flux as of a boundary about those. That for Berkowski, for him, it's just a fish finder on his boat. You can teach a man to fish is a good idea that many people have heard, for sure. And with a fish finder, you can really catch a lot of fish. One time I went boating and fishing, and it was on a lake. And so this is a lake, it's several hundred feet deep at least. Several 400 or 500 feet deep in these spots. So with a trolling motor and a fish finder and then some trolling rods, and then that the fishing line was basically that every 100 feet or so it had a different gradation of the color. We talked about the chromatic and prismatic, and so you just kind of troll along and the fish finder pings some fish, and then you just drop the lines right to where they sit and they hit the bait and you reel them in. We caught our limit that day. Hey, have a great day.